All right, in this video, we're going to be starting our unit on functions in Algebra 1, and specifically, we will be looking at using graphs to relate to quantities. And we'll start off with an introduction and a couple solved examples in this video. All right, so it's a little bit of vocabulary first. What I want to introduce you to, and we'll go a lot more into this in later sections in this chapter, is the two terms, the independent variable and the dependent variable, and how they're represented on a graph. The independent variable generally represents something that changes on its own, that we are not really in control of, or whoever's in this scenario is not really in control of. It changes on its own. And the dependent variable represents something that changes in response to the independent variable. In the examples in this video, the independent variable will be time. We're not in control of time. Time just keeps going on its own. Time keeps changing by itself. And the dependent variable, could be something like distance or speed or height or weight or something like that, something that changes over time, right? And you might have something, for example, for this one, let's have it just be distance. And you might have a graph that looks maybe something like this. Oops. Okay, and so you can see we have a couple places where the graph is constant. That means the dependent variable is not changing, it's constant. And so that's in this zone right in here. There's no change happening, it's flat, it's horizontal. Okay, and then we have one place where the dependent variable is increasing. Distance is increasing. So think about what that means. As time goes by, distance is increasing. Something is getting farther away. And then lastly, we have a place where distance is decreasing. Okay, so as time goes by, distance is decreasing. So we'll be doing quite a few graphs like this today, thinking about whether an object is moving away, moving towards you, is it stopped? What's going on with its distance, and maybe what's going on with its speed. I hope you can tell that in these two zones right here, the object is not moving. It's stopped because its distance isn't changing. Okay? So we can look at a particular example from here. One task you'll be asked to do is to maybe write a story given a graph. And I'm not going to literally write the story out. I'll leave that to you. But I will kind of talk you through it and work through what that story might look like. So I think the first thing to look at really always is to really make sure you get what the variables are. So we have time going by and we have distance from home. And it looks like that, let me do this in blue here. It looks like somebody started out at a distance of 0 from home at their house, right? At the beginning of time, or whenever we started measuring time. And then it looks like they got farther from home, and then maybe think about what happens here, because this is sort of a curve that we're making here. Okay, the object or the person gets farther from home, and they're actually speeding up. Their distance is changing more and more in less and less time. Okay, so this part in here is somewhat slow, and this part in here is pretty fast. Okay, and then what happened? They stopped. We know that because the distance isn't changing. As time goes by, the distance does not change. And then they started moving away from home. They stopped again. And then can you see what's going on here where this graph is decreasing? They're getting closer to home. They stop again. And then they get closer to home and gradually slow down as they get to their house. Okay, so they're stopped here, they're returning here. And then you could add some details to your story, maybe think about why they stopped, why they sped up, why they slowed down, why they turned back. Okay, important thing there is to really think about what the independent and dependent variables are and how they're changing as demonstrated by the graph. Here's another one, graphing a scenario. So here we have a particular scenario or story that we're working with, and we're trying to choose the graph that best represents it. All right, so the air temperature increased steadily for several hours. Actually, by the way, let's take a step back and let's look at our variables. So we have time across the x-axis, the independent variable axis, and temperature is the dependent variable. So we're looking at how temperature changes with time. So the air temperature increased steadily for several hours and then remained constant. And then at the end of the day, the temperature increased more before dropping sharply. Okay, so what I see right away is this increased steadily for several hours, and that is really this part right in here. Okay, that's the only graph that shows that. And let's see if the rest of the story makes sense. It remained constant. Yep, it did remain constant. Temperature increased slightly and then sharply dropped off. Yep, so graph C looks like it's the graph of that particular scenario. So that would be our answer here. Okay, and then this last one we'll do is a little bit more involved, and I really want you to start thinking about the difference between graphing distance and graphing speed versus time. Okay, so for this one, we will be working just with arbitrary time units and distance and speed units. We don't know if we're working with hours or minutes, and it doesn't really matter. We're looking for a general pattern here. Okay, so let's see. A truck driver enters a street, drives at a constant speed. So let's say that this piece right here is the beginning. That's where things start, right? So that's the start, right where he enters that street. So he drives at a constant speed, stops at a light, and then continues. Okay, so it's a pretty simple scenario, right? Truck's driving down a street, stops at a stoplight, and then keeps going. Okay, but we'll be looking at how these two graphs differ here. So, and I think we can just think about distance from wherever the truck driver entered that street. So the truck driver entered that street at time 0 and at distance 0. Okay, let's say that. And it says it drove at a constant speed. So that means a straight line got that truck farther and farther, constantly away from the start. Then it stopped at a light, so that means the distance didn't change. And then it continues. Okay, now I actually want to change that a little bit just to demonstrate something. I think you can see here that it continued at a slower rate. So this is a faster speed, and this is a slower speed. We're not graphing speed, we're graphing distance on the vertical axis, but I think you can see that the truck went faster when our line is steeper. And here is when it was stopped. Okay, so let's think about speed now. And again, my units are going to be just completely arbitrary, okay? And I'll try to match this a little bit up to where we had the first one here. Let's see. I need to adjust this line a little bit just so it lines up with an axis. Okay, so the axis lines up with a grid. And let's see, we had my truck go, it looked like 4 squares over, and then it was stopped for 4 squares. So let's just try to make sure things are relatively consistent between the two graphs. So the truck was going at a particular speed from the beginning, okay? The truck wasn't stopped at the beginning. The truck was going at a particular speed. And then it stopped at a light, okay? So its speed goes down to 0. And its speed stays at 0. And then it goes up, the light turns green, and it goes up to maybe a little bit of a slower speed. Okay, I'll try to draw this here so you can see that it's right at 0, right in there. Okay, so this is where the truck is driving fast. This is where the truck is stopped, and this is where the truck is driving slowly. And maybe you can do a little bit of comparison between the different pieces on the two graphs. Okay. One thing that's a little bit unrealistic here is this shows that the truck right here went from a fast rate of speed to stopped in 0 seconds. So it's almost like it ran into a wall. And so in reality, it probably dropped its speed a little bit more like that. Okay, and same thing with it increasing its speed. Its speed increased over a period of time, over a few seconds or whatever. Okay, but we're just trying to look at some general patterns here. All right, so that's the important thing here is just the connection and the relationship between a distance time graph and a speed time graph. All right, that's a good place to stop right there.